Hello, everybody. It's AASLR once again. I'm Ryan the Shootist here with Greg,
Hi.
and Greg's going to talk to us about puppets. Is that right? Puppets, puppet malware
Yeah.
with strings. That's where I got puppet.
I was thinking, like, what would happen if I had a heart attack during the countdown? So, like, when the screen like pops up, I'm just like,
Halloween was yesterday. I did put bats on the logo for today, but let's not scare people that much. Or let's not scare me. I mean, you're the guy who knows the things. I'm just here to run the thing.
I actually asked my wife's opinion if I should do this while wearing a clown mask and make like some of my code like drip blood or something. I don't know. But she said it was a day late, dollar short. So
yeah, well, close, but it's like missed it by that much.
Yeah,
almost. But anyway, exactly. What have you got to show us, Greg?
So I'm Greg Hatcher. My business partner is John Steigerwalt. We are White Knight Labs. We basically specialize in offensive cybersecurity, so red teaming, penetration testing. We also do some teaching at Wild West Hack and Fest. We taught in San Diego this year. We also taught at Deadwood, South Dakota, and it snowed while we were there. Gross.
Gross.
But anyways,
it melted after like an hour. It wasn't that.
It did. I actually wore like a Hawaiian shirt and shorts to the class that day. But anyways, so I'm going to be teaching some stuff that's right out of our course today. So whenever we write malware, if we're not paying attention, we can put like identifying strings in there. If anyone's ever done any kind of research into ransomware or APT groups, a lot of the times they're identified or attribution is proved by like their strings, or like they do something stupid. They use the same key to encrypt something over and over again. And that's also great if you want to mimic those groups and like fake attribution too. So I believe they can already see my screen. This is an amazing piece of code right here. It's 7 lines long. So all we're doing here is calling message box. So we're importing windows.h and std.io. std.io, you always need that because we're going to be using printf. Actually, we don't use printf. We don't actually need that. But anyways, we're calling the Windows API message box. So let's go over, and my screen should change. So what is message box? If you ever do any kind of Windows programming, MSDN is going to be your friend. It takes 4 arguments, and these are the 4 arguments that we have here. So it's going to do is say, good afternoon, WKL hacks the planet. So let's go ahead and do that, just to show you that it does in fact work. Message box, okay, and there's our little caption. Cool. So kind of a contrived example, right? But now let's go ahead and look at the imports. If anyone wants to follow along, this is actually the Visual Studio tool, x64 native tools command prompt for Visual Studio 2022. And we're going to look at the imports first in the import address table by doing, let's do this manually. So there's this really cool tool called dump bin. And it allows us to look at our binaries, imports, and exports. So we're going to look at the imports first. So imports are things that your binary needs, while exports are things that your DLL or binary provides. So executables always need a lot of things. They need imports. They're very greedy. Whereas DLLs, dynamic link libraries, they're going to export functionality. So if you ever use dump bin to dump the exports in your DLL, it's going to have a huge list of exports for a DLL, and then there's going to be almost no exports for an actual executable. So for this one, we're going to, this would be, actually we're already in lab 5. So we want messagebox.exe. So the imports for messagebox are going to be these. And let's actually try to find messagebox. And there it is. So messagebox lives in user32 DLL. And if you ever don't want to like manually scan, something that we teach in the class is just doing a quick find stir for message box. And there it is. So how can this be used if you're actually like writing malware for red team operations or penetration testing engagements? This can be used for like there's AV and EDR products that are going to pick up on your import address table. So like there's commonly abused things like dbg help.dll, which is what Mimikatz uses to find mini dump write dump. Like mini dump write dump is the function that we can use to dump LSAS memory. So the EDR product is gonna be like, oh, why do you need dbg help.dll? No, we're not gonna open your process or allow you to do that process injection. So also, we're gonna look at the strings for this as well. Message box. We're not going to look at strings for that because there's going to be like no identifying strings. So what we want to do next is, so this is what I would call statically calling a Windows API, and the next thing we want to do is dynamically resolve a Windows API. So dynamic resolve. Okay. So like a little bit more code, but not significantly, right? So when we dynamically resolve a Windows API at runtime, it means we're going to use git load library to load the DLL that we need to get some kind of functionality out of that DLL. So in this case, we'd already know that message box lives inside of user 32. So we're going to use load library to load user 32 into our process. And then we're going to use get proc address to find message box within user 32. So it's like we have to find something to find something else inside that thing. And this is actually going to get much more complicated once we talk about walking the process environment block. We don't have any questions yet, do we? Everyone's like,
no questions yet.
Hear about them. Okay, so same imports here, and then this is our program var proc box message. I know, like really tricky, right? We're calling message box with box message, but anyways, we can name this anything. We can name it zucchini if we really wanted to, and then we're going to load library user32.dll, and then we're going to call it get proc address once we have a handle to user32 DLL, and then we're going to call our message box a. I do have another example of us doing this. So this is basically the same code, except we're just getting, we're using a different DLL. You know, I just mentioned Mimikatz 2014, Benjamin Delpy, really cool tool. Actually, no, was Mimikatz? No, Mimikatz was 2017, I believe. But anyways, so this is dynamically resolving mini dump write dump at runtime. We're using load library to resolve dbg help.dll, and then mini dump write dump lives within dbg help.dll. So we're going to use get proc address to actually get the address for mini dump write dump, and then we can continue using that function within our binary. So why would we do this? It's so that we don't statically call mini dump write dump and dbg help.dll. So let's dump imports for this one, dynamic APIs.c. Okay, if we did everything right, we shouldn't have dbg help in here. Okay, so as you see here at the bottom, you guys can still see my screen. So we did a dump bin. We're finding the imports for our dynamic APIs.exe, this binary. And then inside of that, we're doing a find strip for dbg help. If there's any people that just like specialize in Linux, this is the equivalent of grep. Find strip is the equivalent of grep, except Windows. And actually, if we want to make that case insensitive, we could do a whack I. So that's gone. And what about mini dump is also gone. So that's one way we could do it. And now we're going to go a little bit further into the weeds. there's a problem with what we're doing right now. So we use load library and get proc address. So see that? Get proc address is right there. And load library right there also. If anyone's paying attention to the chat, why would AV and EDR vendors care about get proc address and load library being in our imports? I'm gonna give this like 5 seconds. I don't think anyone's actually gonna reply. Okay. So this method of dynamically resolving our Windows APIs at runtime has been around for a really long time. So there's actually a layer deeper than this. I'm gonna stop sharing my screen for a second. And I'm gonna share my deck screen. I know slide deck terrible, right? Okay. So this is IDA disassembler. So get proc address and load library are still present in our import address table, which is cool, right? We don't have dbg help.dll or a mini dump write dump in our imports anymore, but we have these very, I don't want to say they're malicious, but the way that malware authors use these in their code is malicious because 25 viewers for you. Okay, well, thanks, Ryan. Oh, that's private chat. Sweet. Anyways, so we've been doing this for a long time. Malware authors have, in order to get around having badness in the import address table. So there is, sorry. Okay, so there is another layer. So first off, we started with statically calling Windows APIs by just calling message box, right? And then we talked about dynamically resolving them with load library and get proc address. The third, this is like Inception, right? We're getting deeper and deeper in the operating system, trying to get around all these signatures that AV and EDR vendors are looking for. There's also something called walking the PEB. And then once we find the address of like kernel 32 or NTDLL, whatever we're trying to define, we could use the export address table to pull out the function inside of kernel 32. So this is, I made this content today. So awesome. Hello, haircut fish. Sweet name.
Haircut fish is our meme creator of the chat.
Okay. Anyways, so this is like Inception. We're going deeper, right? So now our goal is to eliminate load library and get proc address from the import address table. And we need to retrieve the base address for kernel 32 or whatever DLL we're trying to use. In the case of message box, we would need to use user32.dll. And in the case of like finding mini dump write dump, if you wanted to use some kind of like Mimikatz functionality, you'd have to do dbg help.dll. So yeah, get rid of that, retrieve base address of kernel 32 and gain access to kernel 32 functions. Why do we need kernel 32 functions? Because that's where almost gosh darn everything is. That's why we need it. Okay, so process my block primer. I'm actually going to switch back to WinDBG now. Bear with me. So many screens. Okay, you should see a black screen. Come on, WinDBG. Come on, man, you can do it. Okay. Can you still hear me? It's really quiet in here. Okay, cool.
We got your screen.
I'm used to like hearing Ryan rustle around in the background, and that's like me telling myself that everything's okay.
Oh, I muted myself because my dog is walked in and is eating something loudly. So I muted myself.
It was weird, like training in a vacuum for a second. Okay, so we're in WinDBG right now, and we need to talk about the process environment block because we need to walk that to retrieve the base address for kernel 32 or user32.dll, whatever you're trying to get to, whatever kind of functionality you need for your malware. So I created a little notepad process down there. Let's do attached to a process. It's always at the bottom for some reason. Notepad, okay. Okay, cool. Okay, so ignore all that. We're going to do display type underscore peb. Actually, we're going to look at the teb first. Okay, so things are about to get kind of weird. What is the teb? The teb is the thread environment block, and we need to get the address to the process environment block from the thread environment block. And how do we do that? Let's look. The peb in x64 Windows. Oh, nope, not the pen, the peb. Okay, cool. So the peb can be found at FS0x30 in the thread environment block for x86 processes, as well as GS060 for x64 process. So in this case, we're going to be looking for GS0x60. So blah, 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 process environment block. And that might be kind of hard to see on the screen. So process environment block 0x plus 60. And that's going to be in the GS register. And then also, I'm going to go over to my code real quick, because we're going to talk about how we can actually do this dynamically at runtime. Like, everything's really cool when we're static in WinDBG and we can just like step through and look at all the DLLs. But like, what if we had to like make one binary and compile it, right? So I just said that the peb is located at GS0x60 for x64-bit processes. Okay, so this is going to be our code. This is like starting the code for our peb block in order to get kernel 32. So what do we do here? Look at these comments: XOR REX into REX. So when we XOR something against itself, it's zeroing out. And by the way, this assembly code, all this is doing is getting us to putting 60 in the GS register so we can get the address to the process environment block. So we XOR REX into REX, which is 0. And this is Intel syntax assembly. This is not AT&T. If there's any AT&T assembly people in here, please leave immediately. And then we're going to move RAX into RBX. So what do we do? Since there's 0 in the RAX register, we moved 0 into RBX. Now we're going to add 62 into BL, which is the lower register, and we're going to subtract 2 from RBX. So remember, we moved 0 into RBX. Excuse me. In the lower register, this has 62. So we're subtracting 2 from 62, which is 60. And then we're moving all of that into RAX and retting. So at this point, RAX is going to be holding 60. I know that's kind of weird, especially if you're not good at assembly or math. That's going to be hard to follow. But we're essentially just doing math to find out where we're at. And that's the whole concept of the peb block. We're essentially walking the process environment block to find out, and we have to like keep adding things together to find out where we're at within the operating system. Okay, so let's go back to WinDBG. No, I don't want that. I want this. Okay, process environment block primer. What is it? Data structure initialized at process creation. So for each thread, there's an equivalent data structure dedicated to the threads. It's called the thread environment block. So we start at the tab to get to the peb. So within WinDBG, I actually put these screenshots here just so like I can't like show my screen labbing and deck at the same time. So this is what I would be doing in WinDBG. So display type tab. In here we have plus 0x60. This is where the process environment block is located. Going down one more. So from the peb, where do we go next? We go plus 18 to the LDR, which is also called the peb loader data. And then we've got the structure for the peb over here. If you, this is like the MSDN output also. So where do we go from the peb loader data? It's kind of like a string that we're pulling, right? So we're going like thread environment block, process environment block, PEB loader data. Where's kernel 32? Where's NTDLL? Let's find out. So from the PEB loader data, we need to locate in-memory order module list, which is plus 20 from the PEB loader data. So see these little ads right here, these addition marks in WinDBG next to all this stuff, the in-memory order module list, the plus 20, and like how the process environment block was plus 60. That's really important because we need to do that math dynamically once we like create our binary. So from the PEB loader data, we need to locate in-memory order module list. It's plus 20 from PEB loader data. So the list entry is kind of weird because it's like a doubly linked list with like flink and blink. Flink is going to go forward and blink is going to go backwards. I know it sounds like gibberish. Microsoft.
That sounds like a comedy duo.
Yeah, like I didn't make this up. Flink and blink, right? They couldn't have called it something else. But anyways, so just think of like each one. Flink is a like a data entry list, and Flink is also a data entry list. So there's data in both, depending on which way you want to go. To get into the in-memory order module list, we need to go plus 10 from loader data table entry. So what is loader data table entry? It's the structure for NTDLL's record of how a DLL is loaded into a process. And actually, there's no MSDN article on loader data table entry, which is really weird. I'm not sure like if we're like too far into the operating system that Microsoft like just gave up on documenting it. So there's this dude, Jeff Chappell. He has blogs in like every single Windows API, I swear to God. So if you're ever doing something and like Microsoft hasn't documented their own thing, he's probably documented it on his blog. So great resource. Okay, and then I made this lab for the course today, so it's gonna be a little rusty. We're gonna do it though. So I'm showing PowerPoint right now. Let's go back to code.
Do you need a drum roll?
No. Can you guys see this?
Oh, I got to turn it on. Then they can. There it is.
Oh, okay, cool. Haircut fish. Good math is not my friend. That's awesome. Okay, so we talked about getting to the process environment block from the git peb using assembly. This is just math right here. And then this is basically a lab. So I don't like spoiler alert, but we're just gonna go through it real quick. And the whole point of this is to essentially use the load library functionality without calling load library. So for instance, like load library kernel 32, to get kernel 32, the base address, we would have to do all this stuff just to get that. This isn't even the get proc address part yet. So you find module base. This is going to find the base address of the DLL. Peb, pointer to the peb, get peb. We're not going to walk all the way through this. Peb loader data, list entry. Hopefully some of this stuff sounds familiar, like in-memory order module list, Flink. We do use Flink to do this. We have to go forward. We're not going to go backward to get the base address of the DLL that we want. And then essentially we have to do a do while loop. That's going to start with like the entrance to the first DLL, and it's going to rotate through the loader data table entry, spitting out all the DLLs as it goes down. And eventually the program inside of main, it's going to call find module base, and it's going to print out like all the DLLs. So remember, all we're trying to do right now is to find the base address of the DLL. So this is pebresolve.exe. Actually, no, I don't want to do that. pebresolve.exe. So in the chat, your binary loads what DLL first, second, and third. Does anyone know? It's the same every single time you load a binary. So if I load like Microsoft Paint.exe, what DLLs are loaded in what order? Man. Ryan, can we give them permission to speak? I want to get some interaction going on.
Permission to speak? They don't have mics. They just have chat.
Okay, never mind. Anyways, so it's going to call the name of our binary first, and then ntdll, and then kernel 32. So if you ever wanted to resolve kernel 32, you would have to do the third DLL that's resolved. So let's do this. And as you can see here, the name of the program is pebresolve.exe. Think of this as like argv0. It's the name of its own program. And then how I said ntdll is resolved second, I guess. It's the first DLL that's resolved. But kernel 32 is resolved thirdly, and then kernel base, and then MSBCRT. If you wanted to load any other DLL after that, you'd have to do like some custom magic. But every single time you load an executable, that is the order. So it's actually very predictable, and this does not change with like AASLR or anything. Okay. There's also going to be a second part of this lab that is not done yet, where we actually use the export address table to. So now that we have a handle to kernel 32, we have to walk the export address table to pull functions out of kernel 32 and then use those in our program. Cool. All right, now let's talk about strings. My mom texted me. I had to check it. Love my mom. Okay, anyways, so revealing strings. So we talked about, even if we're dynamically resolving Windows APIs, our strings are still present, and I can show you that. You know what's on deck right now. We'll stick over here. So anyways, if we were dynamically resolving, our strings would still be present. dbg help.dll and minidump write-dump in the this is like the Mimikatz version, if you will, because Mimikatz uses both of those. And that's a bad thing because static. This is static. This isn't even like heuristic or behavioral yet. Your AV and EDR product are going to look at your binary from a static perspective and be like, okay, what are the imports? What are the strings? What are the URLs that are like baked into it? Like, let's go connect to those in a sandbox and see what the URLs are. Like, are those URLs categorized? Are they blacklisted? I don't know. Okay, so now we're gonna go over to lab. Okay. So dynamic APIs.exe. Answer the. So you need to give it the case insensitive flag. Okay, so although we don't have minidump write dump in our import address table anymore, there's still a string called minidump write dump in our just like string detection, right? And by the way, this program is using strings. It's part of the sysinternals tool suite that Mark Rusinovich created a very long time ago. He leads the Azure team at Microsoft now. Very, very smart man. But strings is still useful. It's been around forever. Okay, so how are we going to get around this? In the course, we talked about building a generator, and we're going to look at the code for that now. Okay, cool. Excuse me. I should not have eaten right before this. Okay, so say we wanted to dynamically resolve minidump write dump at runtime. What could we do? We basically could create a char set and then essentially do like m plus I plus n plus I write dump all the way down, right? Using an index to these values. So from this char set, m would be like some value, I don't know, like 17 in, and then I would be a little bit before that, so like 15, et cetera, et cetera. So hopefully that makes sense. And we can just like rotate through our string and spell it with numbers, and then use those numbers to be like, and by the way, this equals mini dump, right dump. And that'll actually get through string detection, which is really strange, but it works anyways. Oh, that's Ryan just doing stuff. Okay. I'm like, oh, someone posted something. No, they didn't. Okay, so now we're going to talk about the next layer. Okay, so this is the code that basically has string detection bypass for mini dump, right dump, doesn't it? Yeah, it does, and DBG help. And we're also doing some dynamic resolution. This does not have the PEB walk in it. It's going to next time we teach the course. So students will essentially, they'll learn how to statically call a Windows API, then learn how to dynamically resolve a Windows API at runtime to get that out of the imported REST table. But then the EDR can still detect that on an image load event, so then they'll walk the PEB. So that'll be like the last layer of inception, if you will. So how dare you prepare to eat at a time like this? That's awesome. Anyways, so resolve stuff, we just talked about using our generator by building a char set. It doesn't have to be like 1 through 9 and then the alphabet. Your char set could be like something really weird. Like it could use Unicode characters or something, like make it emojis, like, you know, mini dump, right dump could just be like a bunch of like piles of poop or something. I don't know. Use your imagination. Yeah, I've got tons of comments in here. Ignore all that. That's essentially like the function that takes the base64 encrypted string and on base64, I guess it decodes it, I guess, from base64. But anyways, this is the main part that I want to talk about. This is the getting around string detection. So this is essentially spelling dbghelp.dll in that char set. So, and where do we actually, sorry, I haven't looked at this in a while. dbg11, not dbg help. That's funny, not dbghelp.dll. So dbg, as you can see here, dump, mini dump, right dump. So you can even see like DLL. So LL is 2121. D would be like 13. Yeah. Hopefully that makes sense. And then we have just like a normal dynamic resolution at the bottom. Dynamic resolving an API at runtime. No more hard-coded strings. Mini dump, right dump using load library to call not dbghelp.dll and not mini dump, right dump. Remember, we can't just like put in parentheses mini dump, right dump and dbghelp.dll because that would be picked up on string detection. We have to use our fake name that we use our and then we use our encoder/decoder at runtime. So what would this look like if we actually started looking at it under like a microscope with string detection and looking at the imports? Let's check it out. That was lab 8. Isn't it? Or was it 9? Oh, it was 7. That's why. Okay, so let's search for some strings on doublewhammy.exe, and it's called double whammy because we're getting around string detection and import address table hooking. Then let's do, what do we want to do a find stir for? Incentive. Okay, as you can see, it is not there because it's not there because I spelled it wrong too, but it's not going to be there even though it's spelled correctly this time. And then DBG help. DLL. Okay, and that's gone too. And you might be asking, like, how did we get these values? We got these values by using our generator, and I can actually show that real quick. Hold on. I think it is. This is case sensitive because the array has upper and lower in it. Okay, so you guys can still see that, right? Yeah, it's at the very bottom. Here, can I clean that up a little bit? There we go. Okay, so with our string generator, we took this string mini dump write dump, and we did some Python voodoo, and then we essentially converted mini dump write dump into our char set, and it's 17 characters long, and using our char set, it's 48, 18, 23, 18, 39, all the way down. So you're probably asking yourself, where did that 48 come from? Let's go back and look at our char set. 48. So we need a capital M for mini dump. So 1, 2, 3, 4. I'm not going to actually sit here and count every single one, but just take my word for it that 48 is going to be at, or a capital Mike or a capital M is going to be at an index of 48. So that's where that capital M came from. And if you start looking at like loaders on GitHub, you're going to see a lot of this kind of behavior. And actually, there's a new, well, I don't want to say new, but there's also a super easy way to get around string detection. GitHub AORI loader. This is a new loader by Dirk Matter that just came out. And let's look at the source. Okay. It actually might be his other one that he does the string detection bypass stuff. Let's go back. Yeah, it's dump that LSS. Okay. Source. Okay. Okay. So look what he's doing to get around string detection here. Kernel 32.dll. Does anyone know why that works? Come on, there's 25.
Know why anything works.
There's 25 of you out there, right? Is there still 25?
Now there's 26.
There's more people there, but even less participation. I need to like give out a monetary reward to like be able to throw candy at people for them speaking. Anyways, so this dude Dirk Matter, he doesn't build a generator to rebuild his strings on the fly. He just puts them in quotes and puts a comma in there. And why does he have to have a null? Because to terminate the string, we need a null value, right? Okay. So anyways, if you actually look at this under, if you use strings against this, you're going to see kern. Like even if you're looking at on the stack, you just see kern, 4 bytes, and that's all there is. It's really interesting the way, like some of the things that people think of to get around string detection. And look at this. He spells out Windows System 32, dbg help.dll, which is like a really horrible, painstaking way of doing it. I'm sure like he just like used Notepad and did a find replaced to do that. But that's another way that you can do it. I'm saying there's multiple ways to do it. In the course we teach the string generation way, and then we decode it on the fly inside the binary. So cool beans. Let me see if I have anything else. Is this video going to be saved? I don't know. I don't know what Ryan's got up his sleeve.
Yes, it's going to be on the YouTubes and I think Twitch, at least for a little. I think the Twitch stuff expires after a little while, but it's going to be up on our YouTubes for sure.
Okay. I think Oreo Blight is the first real person that has said something, isn't he? Or she?
Besides haircut?
Yeah, besides haircut.
Yes. The first Twitcher.
I decoded it. It just says drink more Ovaltine. That's awesome.
It's a major reward.
Hold on, see if there's anything else that I want to. Final POC. Okay, yeah, there's one more thing that I can go over. Okay, cool. So there's that way of doing it, but there's also a way of like encrypting our imports. Excuse me. So you know how we built that generator? I'm on the tubes learning by osmosis. Nice, Lyle. So we talked about getting around string detection by building that generator. We could do something very similar with our Windows APIs. So for example, we're going to use XOR encryption to just encrypt our APIs and then decrypt them at runtime. So this is really awesome if you have to put something on disk and you want to like encrypt your Windows APIs. Obviously, you want to encrypt your shellcode too. You don't want like your shellcode sitting out there, hanging out on disk, waiting to get eaten by ATP or Sentinel-1. But anyway, so like for this example, S virtual protect, this is going to be virtual protect, and then this would be decrypting it at runtime. Excuse me. And this is just a very generic process injection technique. Looks like we're using virtual protect to change memory permissions, virtual alloc to allocate memory into the address space, and then RTL move memory to like push our shellcode into that memory region. And then we're using virtual protect to change memory permissions again, and then executing with create thread down there. So this is about as generic process injection as it gets. I wanted to show you this because there's more than one way to like get your Windows APIs. Cool. Can anyone tell me a good reason to use XOR encryption for like regarding entropy? Because the AV and EDR products, they detect an entropy as well. So like the closer to 8 you are, which is complete randomness, the worse it is, and you're probably to get flagged. So it's great to use XOR encryption in building your malware because it's actually a very low it's a low entropy algorithm, encryption algorithm. Same with base64, but I would not recommend using base64 because that can be decoded easily. What was your question about why something kernel 32? I missed the question. I asked a question a long time ago about what like the order that an executable is going to load DLLs at runtime, but I already answered that. It's the name of the binary and then ntdll and then kernel 32, like then the kernel base and then msvcrt.dll. Maybe that's what he's referring to. I'm not sure. Okay.
How about this question? What can a blue teamer get out of everything you just demoed? What's the value for a blue teamer?
So the value of a blue teamer, I just went over a very vanilla process injection technique. So to perform process injection, you have to change memory permissions. So if you ever like a great Windows API to detect on if I was building some kind of product or if I was a blue teamer would be to detect on virtual protect, because that is the Windows API that you use to change memory permissions. Like you have to have write permissions to write your shellcode, right? So, and then also if you're a blue teamer, I mean, this was like a very heavy blue team video, like detecting malware via strings. So if you are a blue teamer or SOC analyst and you get some like random malicious binary, like throw strings at it to see if you can pull out some Windows APIs that are commonly abused, like virtual protect, for example, virtual alloc. Are they allocating memory to push their shellcode into? Look for malicious strings, all that stuff.
Cool.
Yep.
You're at the end of your demo, right, Greg?
Yeah. So if you want to learn more about this, and the peb walk / finding like the Windows API functions via the export address table after the peb walk, that's going to be an awesome lab that we're still working on. Haircut fish, I would be a SOC analyst soon. Nice. Hey man, definitely take John Strand's, I think it's called like Pay What You Can SOC course. So I've heard great things about that course.
Yes.
But yeah, that's all I have. If they have any questions for me.
All right. Last call for some questions. We'll give it a few seconds. But in the meantime, while we wait for our last call, I'm going to throw up the link for your class once again. Offensive Development. There's the URL right there, which I know is really long. But if you go to antisyphon.com training and search for one of those words, it'll probably show up. You have Google. You know how to use it. You'll find it.
Yeah. Hey, the training next year, is that public information, Ryan? The info that we got today?
Our schedule is not, I don't know if our schedule is public, so I'll hold on that. But
okay,
if you go to the class page, when things are public, that does get updated. There's also the calendar page, which I can grab that link real quick.
I wasn't talking about like some training we have in the schedule for next year, but we're gonna hold off on that.
Drop the link in the chat, excuse me, for the calendar page. I'll bring it up as well. That changes every week or so or whatever as we add the classes to the roster. You'll see it there. And we're working on a whole bunch more classes, of course, for 2023, and some interesting things that I don't know if we can make public yet, but we're doing some stuff. We're doing things.
Yeah, so John and I, we teach our offensive development course. We had like 55 students at Deadwood at Wild West Hacking Fest in October. And we're also working on creating an Active Directory course with Cobalt Strike. That's going to go, it's like a deep dive into abusing Active Directory certificate services. So if you know Will Schroeder, and he goes by Harmjoy, and Tifkin from SpectreOps, they demoed a bunch of like ADCS attacks last year at Black Hat. And then there's a bunch of tooling that has come out recently since then, like Certify. They dropped that, and then Certifies the Python version. So things to look out for. New courses are coming from White Knight Labs.
Can you make a meme class? Go right ahead, Haircut. Maybe we'll have it at one of our events in the future.
That would be kind of cool. Like how to like automate the process of making memes like really quickly on the fly. I don't know.
He's very fast at it. I will give him that credit. He's optimized his workflow.
Could you say this would be a method to find someone trying to bypass AMSI by not loading things directly? So AMSI is more for like PowerShell and .NET detection. Everything that I showed today, there was C and C++. So if you can do all these methods from C#, it's going to be a lot more code because you have to like use platform evoke in Marshall. But yes, that would be attempting to get around. Would they get around AMSI? That's a great question, man. But yes, we actually have a lab in our course where we get around AMSI with C# by like unhooking the AMSI DLL from the command line. So we essentially like pass AMSI an invalid argument in C# code, and then we like are able to do whatever we want. And remember, once you bypass AMSI, it's just for that process that you're in. Like once you move to a different process, AMSI is still valid, and the AMSI.dll functionality is all still there.
Cool. All right, I think we're going to wrap this up then. Right. All right, I'm going to say it. It's been another episode of AASLR. That's what I'm going to call it now, just AASLR. It's easier to say. It's been about malware with me, the shootist, and Greg Beef here. Greg Beef? Yeah, Greg
Yeah,
Leaf.
it was my
Greg
gamer
Leaf.
tag from Halo 1. I know that dates me. Halo 1 came out in 2002.
Oh, well, you could inject yourself to avoid that, I think. Double A. Yes. Okay. Thanks for the feedback, Tim J. And
Awesome.
as we say, I'm going to now kill it with fire, and we'll see you next time
Die.
on AASLR.
All right, later, y'all. Later.